Hey everybody, I hope that you're doing well. And so, we have been working for 3 whole classes on becoming rock stars at solving systems of equations. Okay? And so we're going to put that to use today to do some problem solving, to work with some word problems. When we hit these word problems, we want to really pay attention to what we know. And we're going to start by, if we can, we're going to attempt to define some variables. Okay. The next thing we're going to want to try to do is look at all the information we have and see if we can write some equations. Now, everything that we have done in this chapter has had 2 equations in it. So you can probably guess that we're going to keep going with multiple equations each of these problems because we're going to have 2 things to solve for, an x and a y. We're going to need 2 equations to solve them. And then finally, we can solve our system. And then remember, the last most important step is to make sure we answer the question. Okay? So this is the same as when we did word problems back in chapter 2. We're going to try to define variables, write equations using all we know, solve our equation that we wrote. 3 and 4 is really the easy part. All the work is really in problem 2. We've already spent a whole bunch of time of solving this whole last week or so on solving systems. So this is all the new work right here, is writing the equations. So what we're going to do is we're going to focus on 3 setups or 3 specific types that'll set you up really nicely for Math 111 and for our coming up test. So here's the first type. We're going to see distance equals rate times time problems again. And they'll look something like this. So an airplane takes 8 hours to travel the distance of 3,600 miles with the wind. That's an important part. The return trip takes 9 hours against the wind. Find the speed of the plane in still air and the speed of the wind. So the easiest spot to define our variables is to look at what we're supposed to find. We want to find the speed of the plane and the speed of the wind. So why don't we just define our variables? So what we're looking for the plane speed. Let's let that be p, speed of plane. And we're looking for the wind speed. Let's let that be w. So that's what we mean by defining variables. See what 2 things we're trying to find, plane speed and wind speed, and let's go ahead and say, okay, let's just let p be the speed of the plane and w be the speed of the wind. So we've defined variables. If you can do that, you can get some partial credit on these problems. Alright, so the next thing we would like to do is we would like to set up equations. Now that's the harder part. So let's imagine this. Let's see if I can draw an airplane. I'm not an artist in the least bit, but I want to kind of give you a visual of, oh, I'm kind of impressed. That's decent. So there's our airplane, and it's flying from here to there, okay? We know that this distance is 3,600 miles, and we know it's flying in 8 hours with the wind, okay? So the wind is helping to push us. So if you don't know this, whenever you're in something that is in the air or in the water, there is going to be a current either pushing with you or against you. And so whenever you were going with whatever, the wind or the water or the air or whatever, you're actually going to travel your speed plus the wind speed, okay? Now the return trip, the plane flies back into the wind. I don't know if I can draw another plane that looks decent, but you're on, I guess, the same plane, and you're flying into the wind or in opposite direction of the wind. So the wind is actually slowing you down, okay? Now, so we did learn earlier that we have this equation, distance equals rate times time, to relate these pieces of information that we know. So we have basically 2 trips here. We have a trip that took us 8 hours, that's our time. We traveled 3,600 miles, that's our distance. And we don't know the rate, how fast we went. And that was with the wind. Against the wind, we have the time. And they don't tell me the distance, but it's a return trip. It's the same trip backwards, so I know the distance is also 3,600 miles. So here's what we're going to look at. We are very aware that distance equals rate times time. And I need to have I'm going to have two equations, so I need to have one for with the wind, and I need to have an equation for against the wind, the other trip. So our two trips, with and against, and that's going to also be distance equals rate times time. And let's see if we can write these. See, I know the distance is 3,600, and I actually know that's the distance for both of these trips. I do not know the rate. We'll leave that as R for a second. Actually, let's leave a big blank parentheses, and we'll fill in the rate. That's the part that takes thinking. But I do know the time. The time for with the wind was 8 hours. And the time of the trip against the wind, where is it at? 9 hours. Okay? So now I just need to figure out the rates. So here's what it's going to be. The speed that you were traveling when you go with the wind is the wind speed plus the plane speed. So W plus P. I do not know what these rates are, these speeds are, but I know the speed of this whole trip is if I add these two speeds together. Does that make sense? So I have a distance equals rate times time. This is my distance, my rate, and my time. These problems, we're going to give you the times and the distances. The rates are always where all the work is. So that's always going to be the part that I'm peeling off of my picture here, and pictures do help. Now let's work on the against the wind speed. So we know we went 3,600 miles. We know we took 9 hours. What is the rate? Well, it's going to be whatever plane speed we have, and we're going to subtract the wind speed this time because the wind speed is taking away from us. Now I may make one change to how I write this. Let's put them in the same order just so it's a little easier to do some math with this. Okay, so I have the with the wind trip and the against the wind trip. So now I can pretty much ignore everything up here and look at what I have. I have a system of equations to solve. And this is actually a really easy system of equations to solve if we go ahead and get rid of this 8 and get rid of this 9. Let's get rid of this 8. How could I get rid of, let me write this equation. Let me write both of these with more space to work. P plus W 8, and the other one 3,600 equals P minus, I'm just rewriting them with more space, no math yet. Okay, so let's look at these and say, how could I make this a simpler equation? This 8 really is in my way. Well, this is multiplied, isn't it? So couldn't I just divide both sides by 8 to cancel that 8 out? Yeah, I'm not going to do any of my tricks yet. I just would like to make this a lot easier of an equation. And let's see, 3,600 divided by 8. What is that going to be? 3,600 divided by 8 is 450, I believe, equals P plus W. So everybody sees I just divided both sides by 8. I get 450 equals P plus W. Just to make an easier equation. I'm going to do the same thing over here. I'm going to divide both sides by 9 because I would really like to just get rid of this 9. Okay. And what that will give me is, let's see, 3,600 divided by 9 is 400 equals P minus W, and the 9's gone. Now, oops, W. I got into these writing these 4's. So now look at what I have is I have a very, very simple system of equations. An elimination would solve this really easily. So I'm going to try to neaten up my work and write this over here. So I have the two equations now. 4,500 equals P plus W, and I don't know what I just said, but 450. And 400 equals P minus W. And so I can do my my solve a system. This is what we've spent the last few lessons on. We're absolutely rock stars now at solving systems. I'm going to use elimination because these W's are set up to eliminate so well. So let's see, 450 plus 400 is 850. P plus P is 2P. And W and minus W, those cancel. So here I sit with this really simple equation to solve for the plane speed. If I divide both things by 2, I will get 425 equals P. So I have found the plane speed. Awesome. So now I need my finishing move. Let's take this and plug this back into the top one. 450 equals blank plus W. And let's plug in that what we found for the plane speed, I said green, is 425. So I need to subtract 425 over to solve for W. And that will just be 25 equals W. So I have solved my system. I found the W and the P. So we need to answer the question, what is the wind speed and what is the plane speed? Well, what's the wind speed? That was W, right? That was 25. And everything in here was miles per hour. What was the plane speed? 425 miles per hour. So I have solved this. I have answered it. Really, the solve below the black line here was actually really easy because we already know how to do this. All the rest of the work is in setting up the equations. So for the test, this is the thing you really need to study hard, is how do I write these equations? And these are distance equals rate times time equations. Distance equals the rate is all the work times time. Okay? Let's look at, you'll get one of those on the test. Let's look at another variety of question we can get on a test. And I've named these all. These are not the technical names of them, but this one is called a mixing problem. Okay, so let's read this. This comes up a lot in other versions of sciences, but we'll do a simple salad dressing one. So one brand of salad dressing is 11% oil, while another is 32% oil. How much of each dressing should be mixed together to get a 15 ounces that is 25% oil? So we have these two salad dressings and we're going to make our own custom house dressing. We're going to mix these two things together, okay? So let's just let X be one of them and Y be the other. So let's just call them X equals amount. Oops, I can't spell. I forgot the N. Amount of type 1 dressing, or first dressing, or whatever you want to call it, and Y be the other amount. Oh my goodness, I'm having a hard time. Amount of other dressing. Alright. And so here's the anytime you do a mixing problem, this is what we're doing. We're mixing the two salad dressings together. So you have some salad dressing, some other salad dressing, and you're pouring them together in this big bowl, mixing them up to create another salad dressing, okay? We need to figure out how much of these two amounts we have. Alright, it kind of looks like a monster or something. I'll erase that. So, the easiest equation is you're always going to start a mixing problem by saying, okay, well, if I mix the two amounts together, regardless of percentages, ignoring the percentages, if I mix the amounts together, I'm just going to get the total amount, which is 15 ounces. So you always have this very easy equation. Amount of the first type plus amount of the second type equals the total amount. I don't care how much percentages of oil are in them. That equation is always a given when I'm doing a mixing problem. Okay, that equation is always easy to come by. X plus Y equals the amount. Notice we're looking at amounts, not percentages. And the other equation is always really easy. You take all the percentages and you basically are going to create another equation with the same structure. X plus, I'm going to leave some space, equals 15, and all of them will get multiplied by their percentage. So let's see, what's the percentage of the first dressing? 11. Can you make that a decimal? That'd be 0.11, right? So 0.11. What's the other one? The Y is 0.32. 0.32, and then the 15, what's the total? 0.25. So 0.25. Okay. So I've done that now. Now I do need to clean this up a bit, and then I could do an elimination or something, or a substitution, whichever way you wanted to solve it. Let's see here. Another way of doing this is actually by not using the decimals at all. Well, no, let's not confuse anybody. Let's leave it as decimals. What I'm going to do then is I'm going to do this multiplication because I need to figure out what this number is. Let's see. Let me grab a calculator here to figure out what 0.25 times 15 is. I have a calculator somewhere. Okay. Everything's going slow. There we go. Calculator. Boom. And so, let's see what 0.25 times 15 is. I like to do lots in my head, but I don't like multiplying decimals. 3.75. All right, so let's trade that out for 3.75. Okay. So now that looks a lot better. Let's see if I can move this out of the way, and we're going to replace it with that one. So there's our two equations. Can I do an elimination? The answer is yes, I can, but I'm going to have to multiply both equations. So look, if I multiply this equation, this bottom one, by 100, it's going to move the decimal back twice for me, okay? And I actually would like to do that so that I don't have decimals. So remember, when we learned last lesson, I can multiply by anything I want to. I'm going to multiply 100, and that'll make these all whole numbers. Let me go ahead and do that because it'll be really easy to see. That's going to be 11x plus 32y equals 375. It just moved all the decimals twice. So if I'd like to cancel x's, all I need to multiply this thing by is negative 11. And that will eliminate the x term. So I'll get negative 11x, negative 11y equals, and 15 times 11, negative 11 I guess I should say. So let's clear this out. 15 times negative 11 is, whoops, it didn't get the negative. Negative 165. 165. Okay, so now we can finally go about doing our elimination. You add them together, the x's, eliminate. Negative 11 plus 32, that is 21y equals, and when we add these together, negative 165 plus 375 is 210. Yeah, 210. And so then I can simply divide by 21. We can do this in our heads because 210, 21, that's just going to be 10. Awesome. So I found how much of the second dressing I have. 10 ounces. So now I just can go to one of the originals. This blue equation is super easy to plug into and find. So let's find x plus y equals 15. Let's see, so that y value is 10. So all I got to do is subtract 10 over. So x will equal 5. So I have the x, I have the y, and of course we should write out, 5 of the 11% dressing and 10 of the 32% dressing. So we have found the amounts. We have answered this mixing problem. Awesome. And it all came from us knowing how to solve this elimination. This was the first time you've ever written one of these style of equations to match it up. But just start with easy with x plus y equals the total amount, and then multiply all three by their percentages to give you this one. And we went ahead and multiplied that. All right, one last type that we need to look at is going to be what I call a counting one. That's not actually the name of them, but that's what I call them. They're counting ones, and they tell you how many of something you have going on. So let's say you're eating at your favorite Mexican restaurant, and you buy 4 tacos and 2 burritos, and it costs you $10.50. Then you go back to the same restaurant, so the same prices. You buy 2 tacos and 3 burritos, and it costs you $9.75. what is the cost of a taco and what is the cost of a burrito. So I'm going to use a T for a taco and a B for a burrito. Okay, B equals cost of burrito. I think it's pretty obvious, and T is going to equal my cost of my taco. So these are what I mean by counting. Do you see they tell you how many tacos and how many burritos equals some amount? If you just look right in there, they're giving you each equation. And this is the easiest in my opinion because it's written there for you. So what they're saying is if you buy 4 times tacos plus 2 times burritos, that is going to equal $10.50. I love the counting ones because they're kind of a classical type of problem. And it's the most obvious equations to write. Look at the next equation. Where's my highlighter again? Let's go with green highlighter. 2 tacos and 3 burritos cost you $9.75. So that second equation says 2 tacos plus 3 burritos equals $9.75. So I feel like that's the easiest. This is the easiest one to write the equation for. Okay. Oh, I can't do an elimination net yet. I need to multiply to get an elimination. Let's see. This is 4t, this is 2t. If I were to multiply this one by -2, I would get -4t, and this +4t would eliminate. So let's do that. Let's just carry this top one over. 4t plus 2b equals 1050. And the bottom one will be -4t minus 6b equals -1950. Sorry, trying to do that in my head really quickly. 1950, let's see. 975 times 2 is 1950. Yeah, that's right, 1950. Awesome. So, now I should be able to do an elimination. Boom. Let's see, +4t, -4t, gone. 2b, -6b, be -4 burritos. And 1050 minus 1950 is -9. I'm going to go ahead and put .00 since it's money. It doesn't really matter. Now I just need to divide both sides by -4. Okay, -4. And so b will equal 9 divided by -4 is 225. Negative, negative, make a positive, so 225. There's our burrito cost. So all I need to do is plug into one of the originals. Maybe this blue one's the smallest number, or maybe the red one, it doesn't really matter. And I can find the cost of the tacos. So 2 tacos plus 3 burritos equals $9.75. And so we already know how to do all this solving stuff, so I'm not taking too much time on it. Put in the cost of the burritos. Green. And let's see. 3 times this would be $6.75 equals $9.75. And you can use a calculator for all this. I enjoy trying to do some of it in my head. It keeps my brain from melting to mush. Because I feel like when I don't do things like this, my brain just disappears and I can't even remember my name. So subtract the 675 over. This just keeps me sharp. 975 minus 675 is 3. And then if you divide both of those by 2, I will get t equals 150. So what are the costs of the burritos? $2.25. So the burritos are $2.25, while the tacos are $1.50. So there. Awesome. So I like these setups because I feel like the equations are just given to you really easily. Those are my favorite. Alright? All right, well, that's all I have for you. Those are the three that we need to know how to set up. I think, in my opinion, the hardest is the distance rate time one. So make sure you spend some time looking at that. If you need to go back and rewatch that part and pause and think about what I'm writing and how I'm getting these things, especially how I'm writing the equations and this weird step I did to get it alone, go rewatch that and think about it a little bit and make sure you understand it, all right? All right, awesome. You guys have a wonderful day.